Seventh grade. So we are going to continue with the idea of probability. If you remember last week, we talked about probability and finding the probability of an event and the difference between theoretical and experimental probability. So this week we're going to continue with the theoretical probability, not the experimental. And we're going to talk about compound events. So finding the probability of compound events. Now, compound simply means more than one event. So that's pretty easy. So we're going to find the probability of more than one event happening. Now, there are two types of compound events that are categorized into either an or event or an and event. So the probability of this or this happening, which is much different than the probability of this and this happening. Okay, so we're going to focus on the or first. So we're going to say, how do I find the probability of a compound event when we're talking or? What's the probability of drawing a red marble or a blue marble out of the bag? When I have a little choice like that, my probability is actually a little bit higher because you will actually add the probabilities of your two events. So in the case of the marbles, I would add the probability of finding a red marble plus the probability of getting a blue marble to get my total probability. Okay, so for example, okay, remember this is our notation for probability. If I had a standard deck of cards, which is 52 cards, what is the probability that I would draw a king or draw a queen? Now, if I told you folks, hey, I'm going to give you $10 if you draw a king, you might be like, oh, it's not a great chance of winning. But if I said a king or a queen, now you're thinking, all right, that's a little better because there's more cards I could possibly draw that would get me to win that money, right? So what we're going to do, or means add, we're going to probability of finding a king plus the probability of finding a queen. So if you remember, the probability of getting a king, there are 52 cards in a deck, 4 of them are kings, plus the probability of getting a queen. Again, there are 52 cards in a deck, and 4 of them are queens. Now, yes, you have to add fractions at this point, but the good news is we already have a common denominator. So that means our denominator will stay at 52, and 4 plus 4 is 8. So we have an 8 out of 52 chance of drawing a king or a queen, which is a much better probability than either one individually. Now, yes, we do have to reduce this fraction. I've run out of room. It reduces to 2 out of 13. So you have a 2 out of 13 chance of drawing a king or a queen. That's as simple as or is. You just add the probabilities together. Now, some of you may have said, well, Mrs. Lang, I could have just said 4 kings, 4 queens. It's 8 out of 52. Yep, you can do that too. Okay, another example. So if I'm rolling a standard 6-sided dice, what is the probability that I will roll a 1 or roll a 3? Well, rolling a 1, there are 6 sides to that dice. Only one of them has a 1 on it. Plus, rolling a 3, there are 6 sides to that dice. Only one of them has a 3. Again, I already have common denominators, so when I add that, I get 2/6, which reduces to 1/3. So you have a 1 out of 3 chance of winning the game if I said you could roll a 1 or a 3, which isn't bad. That's 33.3% chance. Okay, so there's an example of or. Now, here are some more or examples. Now, we're going to go back to drawing cards again out of that deck. And this time I'm saying, what is the probability of drawing a face card? Now, you may be saying, well, Mrs. Lang, I don't see the word or. So how is this an example of a compound event with an or? Well, how do I draw a face card? How do I know that I have drawn a face card out of a deck of cards? Well, ladies and gentlemen, a face card is a king or a queen or a jack. So you may see a problem that you don't specifically see the word or, yet it still is implied, because how do you get a face card? You either draw a king or a queen or a jack. And that's how you get the probability of a face card. And again, I can add them together. King is 4 out of 52. Queen is 4 out of 52. Jack is 4 out of 52, which gives me 12 out of 52. Okay, 4 plus 4 plus 4 is 12, which does reduce to 3 out of 13. okay? So that's my probability of getting a face card. The or is implied. Same thing with if I roll a standard dice, what's the probability that I will roll an odd? Again, we don't see the word or, but how do I get an odd number on a dice? I need to roll a 1 or a 3 or a 5. That's where the or comes into play. So that's 1 out of 6 plus 1 out of 6 plus 1 out of 6, which is 3 out of 6. Whoops, sorry. And reduces to 1/2. And some of you may have said, Mrs. Lang, I could have jumped right to the idea that I know half the numbers on a dice are odd. That's fine. I'm just showing you another way that this is technically a compound event where we are adding them together. And that is it. That's how or events work when finding probability. You simply add the probabilities together, whether it is only 2 of them. Here we only had 2, or more than 2. Each here we had 3, but you could have more than 3. Compound just means more than 1.